I was having coffee with an old friend last week, a senior consultant who spent 30 years overseeing infrastructure projects in Western Europe. He looked exhausted, but he had this triumphant glint in his eye as he slammed a massive leather-bound binder onto the table, beaming. After 8 years of environmental litigation, 3 rounds of union negotiations, and a dozen public hearings that nearly turned into riots, they finally had the permit to upgrade a single pier at one of the continent's major ports. To him, this was a masterpiece of democratic compromise, a hard-won victory for the system. He started explaining the intricacies of the veto points he'd cleared, looking for a nod of approval. Instead, I pulled up a video on my phone that I'd received that morning from a contact in Ningbo. It was a 30-second drone clip of a new, fully automated terminal. There wasn't a soul on the ground. Thousands of containers were being shuffled by AI-driven cranes and silent AGVs with the rhythmic, terrifying precision of a Swiss watch. No strikes, no litigation, no bird-watching lawsuits, just the cold, frictionless conversion of data into physical movement. As the video played, his smile didn't just fade, it evaporated. He looked at the 500-page permit on the table, the physical embodiment of his life's work, and then back at the screen where machine was doing in seconds what his port took hours to coordinate. He muttered something about human rights and the cost of soulless efficiency, but his voice lacked conviction. It was the look of a man who realized he had spent a decade perfecting a typewriter, while the rest of the world was moving to the cloud. That hollow look in his eyes wasn't just about one port. It was the realization of a widening civilizational rift. While we've been busy perfecting the art of no, building a labyrinth of vetoes and procedural hurdles, a new kind of power has emerged. It's not based on who has the best arguments or the most likes, but on who can move atoms as fast as they move bits. It's a shift from the hegemony of discourse to what some are calling flow hegemony, where the ultimate verdict on a civilization isn't found in its ballot boxes, but in the sheer undeniable efficiency of its industrial spine.
Flow hegemony. That's the key. That's the phrase that just ties everything together that we're looking at today.
It really is. I mean, we're staring at this stack of material China's industrial plans for 2026. These theoretical frameworks for something called the physical internet. Analyses of Western political paralysis.
And they all point to the same thing. They all point to this massive fundamental shift in what power actually is.
It feels like the ground is moving under our feet. For, 30, 40 years, we've operated under the assumption that power was about controlling capital markets.
Or controlling the narrative, political debate, soft power.
Exactly. And all of this material we have in front of us seems to be screaming that we are pivoting violently back to something much more tangible.
Back to physics.
Back to physics. It's about the sheer brute force efficiency of your industrial spine. Can you make things and can you move them?
And it sets up this incredible contest between two completely different civilizational operating systems. You have one that is, as your friend discovered, almost designed for paralysis. It's built around the right to say no.
A masterpiece of compromise.
A masterpiece of compromise. And on the other side, you have this technocratic execution engine that is just accelerating. And we're not talking about abstract economic figures here, GDP points.
No, this isn't about numbers on a spreadsheet.
It's about the literal movement of atoms across the globe. It's logistics. It's the physical world.
So let's get right into that machine there. We have to understand what this flow hegemony actually looks like on the ground in practice, because it's not a metaphor.
No, it's an engineering project.
It's called the physical internet. And to understand it, I think we have to talk about a guy named Zhang Min.
Right, the logistics coordinator in Ningbo.
Exactly. So in early 2026, he's working at the Ningbo Zhoushan port. Now, if you picture his counterpart in, say, Rotterdam or Los Angeles,
you
imagine chaos.
Right. Constant stress, shouting, radios crackling, guys in high-vis vests running around. It's a symphony of controlled and sometimes uncontrolled chaos.
But Zhang's world is silent. The descriptions of his workspace are fascinating. It doesn't look like a port control tower. It looks like a high-end esports gaming setup.
Multiple monitors, ergonomic chair, quiet. The silence is the most important detail there.
Why?
Because silence in a complex system like a port is the sound of friction being eliminated. Noise is inefficiency. Noise is problems. Silence is flow.
So Zhang is just sitting there watching this flow happen.
Yeah.
And the story we have here describes this one specific incident. A sudden storm surge is forecast, a threat to the entire terminal.
In a traditional port, that's a 5-alarm fire. That's a week of panic, phone calls, trying to manually reroute thousands, maybe tens of thousands of containers.
You'd lose cargo. There'd be massive delays.
Sure, but Zhang, he just watches his screen. He doesn't touch anything.
And a fleet of what they call automated agents. The AI reroutes 10,000 containers in a matter of seconds.
The whole grid just re-optimizes itself.
He's not managing chaos. He's overseeing a system that has the mathematical certainty of a heartbeat.
It's the difference between being a firefighter and being, I don't know, a gardener. One reacts to disaster, the other cultivates a system that prevents it.
So let's peel that back, because it's not just about having bigger cranes or faster trucks. He's overseeing this thing called the physical internet.
Which, again, sounds like a cool branding term, but it is a very specific technical paradigm. The research here, especially from people like Benoit Montreuil, is key. They've been working on this for years, arguing that our current way of doing logistics is, frankly, broken.
It's unsustainable.
Yeah.
I love the way they describe truck drivers as modern cowboys.
It's romantic, but it's an admission of total inefficiency, right? A lone operator on an unpredictable frontier. The data is shocking. Something like 40% of truck miles in the US are driven empty.
40%.
Warehouses are mostly just storing air. There's no real-time coordination between rail, shipping, and trucking. Yes.
So the physical internet, or PI, sets out to fix this. The analogy is right there in the name.
It's a direct analogy. It's asking, what did the digital internet do for information, and can we apply that exact same logic to physical objects?
Yeah. When I send an email, it doesn't travel as one single letter.
Right. Your email is broken down into tiny digital packets. Each packet has a little bit of information, an address, a sequence number.
And they all find their own way through the network.
Exactly. They get passed from router to router, node to node. They might take completely different paths, but the protocol ensures they all arrive and get reassembled correctly on the other end. You don't see the complexity, you just see the email.
The system handles the flow. So the physical internet does this for atoms, for boxes.
For boxes. Instead of digital packets, you have physical packets. And the core of that is the Pi container.
The Pi container. This is the fundamental building block.
Forget the standard TEU shipping container for a second. That's a great invention, but it's too big and clunky for the last mile. The Pi container is modular.
Go.
The specs describe these standardized boxes, starting tiny, maybe 0.12 meters, and scaling all the way up. And the key is that they are designed to physically lock together.
So no more pallets, no more shrink wrap.
The pallet is waste. The container is the pallet. It is the unit. You can snap 100 small boxes together to form one large, structurally rigid block.
Which is already more efficient for moving and stacking. But that's not the really revolutionary part.
No. The revolutionary part is the smart tag. Every single Pi container, from the smallest to the largest, has an agent embedded in its frame. An RFID tag, GPS, a little bit of processing power.
A box has a brain.
The box has a brain, correct. The tag holds encrypted data. Its origin, its destination, its weight, its contents, its priority level. The box knows where it is and where it needs to go.
And it communicates that to the network.
It communicates that to everything around it. This enables what they call distributed automation. You don't need a big central computer telling every crane what to do. The container arrives at a sorting hub and essentially announces, I'm here, I need to go to Berlin on the next available train. The sorting machine just listens and obeys.
The cargo routes itself.
The cargo routes itself. That's the paradigm shift.
Okay, so that's the software layer.
Yeah.
How does this change the hardware? The things we see moving in that Ningbo video. The Pi movers.
This is where it gets really clever. The documents talk about forklifts without forks.
Which sounds possible.
It's not if you change the container, because every Pi container has a standardized frame with locking points. The movers don't need to slide forks underneath and risk tipping it over. The machine just latches on.
It snaps directly onto the frame.
From the top, from the side, whatever is most efficient. It's a secure mechanical lock. It's faster, it's safer, and it means you can pack containers much, much more densely. There's no wasted space for forks.
But the hardware that really seems like science fiction is the flex conveyor. I had to read this section twice.
It is mind-bending. We're all used to conveyor belts, right? A rubber loop that moves in one direction.
Yeah.
The flex conveyor is not a line, it's a surface. Imagine the entire floor of the warehouse is a grid made up of thousands of individual motorized cells.
So the floor itself can move.
The floor itself is the conveyor, and these cells, they coordinate like a swarm of insects. If you place a large container on the floor, a block of, say, 100 cells underneath it will activate in unison to slide it north.
While at the same time, a single parcel on the other side of the room can be moved east by just 1 or 2 cells.
Exactly. You have no lanes, you have no fixed paths. The entire floor is a dynamic mobility web that can move any object in any direction, all at the same time, without collisions.
That's what Zhang Min is looking at on his screen.
That's the Silent Symphony. It's a warehouse that reconfigures its own physical layout in real time, second by second, based on the optimal flow of goods.
The warehouses themselves. The Pi nodes.
This follows the same logic. They call them snapping stores. Because the containers themselves are modular and interlocking, you don't need shelves. You don't need massive steel racks.
You build the warehouse out of the infant.
You literally do. You can stack and lock the Pi containers into a stable, freestanding structure. As new shipments arrive, you add to the structure. As goods are shipped out, you dismantle it. It's called high-velocity composition and decomposition. Your warehouse is alive. It grows and shrinks with demand.
This is the frictionless conversion of data into physical movement that my friend saw in the video. And the scary part is, it's not a 30-year future plan. The data we have from the Trax Technologies report, China's Global Supply Chain Report 2025, says this is happening now.
The numbers are stark. By 2024, China's Innovation Index for Supply Chain Tech had already hit 2.16. That's a massive rate of change, driven specifically by AI and green tech integration.
And the scope of it is what's key. It's not just for shipping iPhones.
Point. The report lists 17 different product categories where this is being implemented. It's everything. Drones, medical equipment, wine, even soybeans.
Yeah.
They are building this physical internet as the new backbone for their entire economy.
There was a word of caution in that report, though. It flagged the resilience index as being much lower, around 1.22.
And that's the Achilles heel. This is a system designed for hyper-efficiency, which means it's incredibly tightly coupled. Everything has to work perfectly.
If one node goes down,
the whole network can seize up. If a truck that isn't Pi compliant tries to enter the system, or if there's a data outage, the beautiful silent flow turns back into a catastrophic traffic jam.
Which is why the report stresses joint industry efforts. It's an all-or-nothing system. You're either on the network or you're not.
You have to have total buy-in. It's a system that demands conformity to the protocol.
And that kind of explains a weird detail from one of the tech expos mentioned. The humanoid robots performing Tai Chi. At first, it seems like a silly PR stunt.
But it's a signal.
What?
It's signaling that their vision for AI is moving beyond simple, repetitive automation, like a robot arm welding a car door. Tai Chi requires balance, complex motor skills, adaptability. They're signaling their intent to automate the messy, unpredictable, human-shaped parts of the physical world.
To make sure no link in the chain can ever break.
To make the system fully resilient by removing the last, most unpredictable variable, us.
So that's the machine in the East, this physical internet, a system that is beginning to treat atoms like bits, a silent symphony. Now we have to turn to the other side of the coin. Because while Zhang Min is watching this perfectly optimized flow, we have his counterpart in Europe, the engineer, Julian.
And Julian is experiencing a very, very different kind of silence.
It's the silence of a project that's been dead in the water for 4 years.
The silence of paralysis, the silence of Vitocracy.
Julian's story is, it's just a chronicle of frustration. He's an infrastructure engineer, a builder, and he spent 4 years trying to get a single permit for a high-speed data corridor.
And we should be clear, this wasn't some mega project. This wasn't a new airport or a dam.
No, it was a trench. A trench to lay fiber optic cables to connect a few regional factories. It should have been a routine utility upgrade.
But it became what he calls his cycle of paralysis.
The list of obstacles he documents is just absurd. He had environmental vetoes because the proposed route might disturb a particular species of moss.
Okay.
Then noise complaints from a community group that lived 3 miles away from the construction site.
3 miles.
Then a series of legal challenges from a competing telecom company, just designed to bleed him dry with legal fees. The project ran out of funding before they ever put a single shovel in the ground.
And in his writing, he contrasts this experience directly with what he was seeing coming out of China at the same time.
He does. He points to the industrial AI grid being deployed in the Yangtze River Delta. While he was sitting in hostile town hall meetings being shouted at about moss, an entire region on the other side of the world was deploying a self-healing, AI-managed power grid.
And they did it by technocratic fiat.
The phrase he used just captures it all. He called it civilizational exhaustion. He felt like his entire society had lost the will to build, that it had become so obsessed with prioritizing the individual right to say no that the collective necessity to build had become impossible.
And this is a perfect illustration of the concept of Vitocracy, which comes from the political scientist Francis Fukuyama. Distinction. This isn't just bureaucracy.
Right. Bureaucracy is slow because of rules and paperwork.
Vitocracy is paralyzed because the system is designed to give an enormous number of actors, both inside and outside the government, the power to stop things from happening.
These are the veto players.
Exactly. A local zoning board can be a veto player, an environmental NGO, a historical preservation society, a labor union, a rival corporation. Each one holds a veto point.
And their individual concerns might even be legitimate. You don't want to pave over a rare ecosystem.
But Fukuyama's argument is that when you aggregate all of these veto points, you create a system where collective action on any large, important project becomes functionally impossible. You can't build a high-speed rail line. You can't upgrade the power grid. You can't permit a new factory.
You can't even dig a trench for a fiber optic cable.
The system defaults to no.
And when you put that system up against what's described in China's AI Plus initiative and their 15th five-year plan, the contrast is, well, it's brutal.
The documents we have from CSET and the National University of Singapore are really clear about this. They show a deliberate strategic shift. China's not just talking about digital foundations anymore. The new mantra is AI everywhere.
This isn't AI as a feature on your phone.
No, this is AI as the central driver of national modernization. It's the new operating system for the country itself.
And they're literally re-engineering the physical geography of the nation to serve this goal. The East Data, West Computing strategy is, it's one of the most ambitious infrastructure projects in human history.
Let's break that down because the logic is so simple and so powerful.
Please.
China's East Coast, Shanghai, Shenzhen, is where all the economic activity is. It's where the data is generated. It's expensive.
Right.
China's West is the opposite. It's vast, it's sparsely populated, but it has incredible potential for renewable energy. Sun in the Gobi Desert, wind on the plains.
So they're building a national brain, but splitting the functions.
They're building something called the China Computing Net. It's a unified national grid for data. All the heavy-duty, energy-guzzling computation training, massive AI models processing enormous data sets get shipped out west, where the energy is cheap and green.
Well, the tasks that need near instantaneous response times.
The latency-sensitive stuff, like Xiamen's automated cranes at the port or a financial trading algorithm that stays in the east, close to the action.
It's a national-level optimization of compute. And the key thing is it's being done by fiat. There is no town hall meeting in Xinjiang to debate the environmental impact of a new data center campus.
The decision is made and the machine executes.
Okay, but this brings up the big question, the choke point we've all been hearing about for years. Semiconductors.
Yeah.
The U.S. has put enormous effort into blocking China from accessing high-end chips from NVIDIA or ASML. How can they build this AI everywhere future without the best hardware?
That is the trillion-dollar question, and the answer seems to be coming out of the Yangtze River Delta, specifically Shanghai. This is where the state has marshaled its resources to create a sovereign, good-enough supply chain.
And the key player here is a company called SME.
Shanghai Microelectronics Equipment. All the intelligence points to them having finally cracked and delivered domestic 28-nanometer lithography machines.
Now, to anyone who follows consumer tech, 28 nanometer sounds ancient. Your iPhone is on a 3-nanometer chip.
It does sound ancient, but this is the critical misunderstanding. First, you don't need a 3-nanometer chip to run an automated warehouse or a smart power grid. And second, through a technique called multi-patterning, they can use these 28-nanometer machines to produce chips that have the effective performance of a 7-nanometer chip.
So they run the silicon wafer through the machine multiple times to etch finer and finer details.
It's less efficient than using a state-of-the-art EUV machine from ASML, but the end product is good enough.
And good enough is the key.
It's good enough for 95% of industrial and military applications. It's good enough to make them immune to Western sanctions. They are methodically closing the gap and eliminating their dependency.
And they aren't just building the capacity, they're forcing its adoption. The AI Plus plan has these mandates.
Top-down, non-negotiable mandates. By 2027, 70% penetration of AI agents in all key industrial sectors. By 2030, that number goes to 90%.
It's not a suggestion, it's an order.
It's an order, and it extends to every facet of life. They talk about good houses, integrating AI into the entire life cycle of residential buildings, from construction to energy management. They talk about whole process intelligent paperwork for government services.
The one that really stood out to me was proactive planning. The idea that the government's AI predicts what services you need. A permit, a subsidy, a license, before you even apply for them.
On the one hand, it's the ultimate in user-friendly government. On the other, it requires a level of data collection and surveillance that is total.
But let's bring it back to the contrast. You have Julian, our engineer, spending 4 years battling for a single permit. And on the other side, you have a system that not only grants the permit instantly, but proactively tells you that you needed it.
If you are an ordinary citizen who just wants to build an extension on your house, or an entrepreneur who just wants to open a factory, which system seems more effective? The one that offers paralysis or the one that offers speed?
And it shows that this isn't just about economics, it's a true contest of operating systems. But none of this, not the physical internet, not the China computing net, gets built without capital. Massive amounts of capital. Which brings us to the third leg of this stool.
The money and the fundamentally different ways the two systems think about it.
To understand this, we need to look at the story of Elias. He's the polar opposite of Julian. He's not a builder. He was, until recently, a hedge fund manager in Manhattan.
A creature of the virtual age.
The absolute embodiment of it. He spent 2 decades of his life believing that wealth and power were abstract things, numbers on a screen that you can manipulate through clever financial instruments.
And in 2026, he has this crisis of faith, an epiphany.
He's watching the global commodities markets, and he starts to notice something strange. Prices aren't moving based on futures contracts or market sentiment anymore. They're moving based on the real-time output data coming from these new automated industrial agents in Chinese factories and ports.
So the AI running a factory in Shenzhen is having a more direct impact on the price of aluminum than a trader in New York.
The flow of actual atoms was starting to overpower the flow of speculative capital. Elias had this horrifying realization that financial power had become decoupled from real-world power.
He realized that the person who owns the factory, and more importantly, the AI that optimizes it, holds more tangible power than the person who owns the debt on that factory.
He called it the end of the virtual age. The moment the simulation became less important than the reality it was supposed to represent.
And his personal crisis is a perfect window into the larger Western pathology described in these Levy Institute papers on the financialized bubble economy.
We've spent 40 years investing in the simulation.
We have. We've been investing in assets, not in productive capacity.
Right.
Our primary economic activity is no longer making things. It's waiting for the things we already own to become more expensive. Real estate is the core of it. The cash flow from the real estate sector alone accounts for over 1/4 of U.S. national income. We're a nation of landlords, not builders.
And our entire incentive structure, our tax code, pushes us in this direction.
Absolutely. We tax income from capital gains, from speculation, at a much lower rate than we tax income from labor or production. So if you're a rational actor with $1 billion, what's the smart thing to do?
You don't build a new semiconductor fab, which is risky and takes years to pay off. You buy up apartment buildings in a growing city and wait for the prices to rise.
You buy land, you don't build factories. And the result is what these papers call a post-industrial economy. An economy that doesn't generate new value through production, but instead borrows against its own constantly inflating asset bubbles to pay its bills.
So we're essentially taking out a mortgage on our own house to buy groceries, while China, the factory owner, is using its profits to build the physical internet.
Elias's epiphany is that moment of realization. It's the great power reality check. You can't print your way out of a supply chain collapse. You can't financialize a new power grid into existence. At some point, you have to actually build something.
There's a really interesting piece from Arena Magazine in our materials, The Street and the Forge, that adds some important historical context here. It makes the point that it wasn't always this way.
No, it's a crucial piece of nuance. Wall Street wasn't born a casino.
J.P. Morgan didn't get rich trading derivatives.
Right.
He financed the railroads.
Yes.
He financed U.S. Steel. He bailed out the entire U.S. government.
He financed the Allied victory in World War I. Finance, in its original form, was what the article calls a risk-enabling technology. It was the essential tool for pooling massive amounts of private capital to build the tangible industrial backbone of the nation.
So what went wrong? When did the street abandon the forge?
The consensus points to the 1980s and 90s. The shift to a shareholder value model of capitalism, the rise of stock buybacks, the aggressive offshoring of manufacturing, a belief took hold in Western boardrooms and governments that making things was low-value work.
The dirty work.
The dirty work. The belief was that America could just be the global designer, the global banker, and the global policeman, and let other countries handle the messy business of manufacturing.
And now the country that handled the manufacturing has built its own design labs and its own banks.
And is rapidly building a military to match. The great power triad has always been military, industry, and finance working in concert. The West has spent the last 30 years believing it could get by with just one and a half of the three.
So you see some attempts to course correct now. The piece mentions J.P. Morgan launching a huge $1.5 trillion fund in 2025, specifically for reindustrialization. You have the American Dynamism venture capital movement.
There are signs of life, there's an awakening, but the core question is, can you do it? Is it even possible for a hyper-financialized economy to pivot back to being an industrial one? It's basically unprecedented in modern history.
Europe tried to deindustrialize through regulation. The U.S. did it through financialization. It might be even harder to undo.
It might be. The incentives are so deeply entrenched.
Which brings us back to the central conflict, flow hegemony versus the ballot box, the hedge fund.
The veto point, the quarterly earnings report.
The Chinese scholar in our sources, Lu Feng, he makes a very provocative, very blunt argument. He says, an industrial power has never lost to a financial power.
The counter-argument, of course, is Britain. Britain was the world's dominant industrial power, and it lost its position to the United States.
But the U.S. wasn't just a financial power.
The U.S. in the early 20th century was both. It was the world's greatest industrial power and its most dynamic financial power. It had both the street and the forge, and they were working together.
So true hegemony, real, durable power, lies in the integration of the two.
And that's exactly what China is attempting to do now. They're fusing their industrial might with a state-directed financial system to build this ultimate efficiency machine, the physical internet. They're betting that this fusion creates a form of power flow hegemony that the West, in its current state, simply cannot compete with.
So, if we pull all of these threads together, we have Zhang Min in his silent control room in Ningbo, we have Julian, the paralyzed engineer in Europe, and we have Lias, the disillusioned banker in New York.
3 snapshots of this civilizational rift. And it's a rift that isn't measured in GDP or stock market valuations. It's measured in something much more fundamental. It's about resilience. It's about capacity.
When the next crisis hits, and there will always be a next crisis, whether it's a climate event, a new pandemic, a geopolitical conflict, who is better positioned to respond?
Is it the civilization that can hold 6 months of public hearings to debate the ethics of the emergency measures?
Or is it the civilization that can reroute its entire national supply chain in 6 seconds by an AI-driven fiat?
It's an uncomfortable question.
Because it implies that we're moving from a world governed by discourse, a world where the best argument wins, to a world governed by flow, a world where the victory goes to whoever can move atoms fastest.
That's the brutal reality of the 21st century that this material lays bare. The physical internet isn't just a project to make logistics cheaper, it's a national survival strategy.
It's a sobering thought to end on. We started this deep dive with my friend in his 500-page binder, a victory of process that took 8 years to achieve. And we've ended with a machine that acts in milliseconds. If the ultimate verdict on a civilization is found not in its debates, but in the raw efficiency of its industrial spine, where does that leave a society that has spent the last 50 years perfecting the art of stopping things from being built? When the storm finally comes, the veto is not a shield. The only safety lies in the capacity to act. And right now, one side of the world is building a machine that acts with the certainty of physics, while the other is still arguing over the permit.
We have to remember how to build things. We have to rediscover the forge, because if we don't, we're going to be left watching the flow from the sidelines.
We'll leave it there for today. A massive, complex topic, but an essential one. Thanks for diving in with us.